Good morning, afternoon, or evening, cats and dogs. Today's video will focus on the lesson 1.6 guided notes on solving proportional relationships. We've already worked with proportional relationships in our previous lessons, but now we're going to work specifically with proportions. A proportion is an equation stating that two ratios or rates are equal. And a lot of times we're going to set up proportions to represent real world word problems, and we will solve those proportions by solving for one of the missing values in that proportion. So we're going to start with some pretty straightforward questions where I give you a proportion, one of the elements is missing, and we need to solve for that missing variable or that missing number. So what we need to recognize is that the cross products of a proportion are equal. So a proportion is two fractions set equal to each other, and if we cross multiply, those cross products will be equal. So if you want to solve a proportion for a specific variable or unknown, you're going to cross multiply and then solve the resulting equation. So number one down below is done for you. We have x over 9 equals 16 over 12. So we cross multiply. We take 12 times x and 9 times 16 and set them equal to each other. 12 times x is 12x. 9 times 16 gets us 144. Right here in this yellow highlighted step, we end up with just a one-step equation. We solve that by dividing both sides by 12, and we get that our missing value is 12. Are there other ways to figure out these solutions? Absolutely, but this is a really straightforward way to solve for a missing variable or a missing value in any two fractions that are set equal to each other. So let's take a look at number two. And I do want to mention that when you get into algebra, for example, you apply this to more complicated proportions where you might have something like 32 over 28 equals 3w minus 8 over 7, and you have to solve for w. So this is why we set the foundation here. So at number two, we're going to take 28 times w and 32 times 7 and set them equal to each other. I always like to put my variable on the left, but it doesn't matter which side it's on. So it's going to get us 28w equals 224. That's 32 times 7. Divide both sides by 28, and w is 8. It won't always be a whole number or an integer, but in this case, it does happen to be. I do often have students who recognize that 7 times 4 gets us 28, and if we think what times 4 gets us 32, that means that W has to be 8. That's okay as well. But again, setting up a proportion and solving proportions is one way that will always work. So let's take a look at number 3. Let's take 36 times S and 21 times 24. So we have 36S equals 504. That's 21 times 24. Divide both sides by 36 to get S equals 14. And we're going to go through these pretty quickly. We'll give you a chance to try some independently as well. All right, number 4, we have 42 over A equals 56 over 8. You might even recognize that 56 divided by 8 is 7, so that might even help you figure out what A has to be here. But let's cross multiply. Take 56 times A and 42 times 8. 42 times 8 is 336. Divide both sides by 56. A equals 6. You will see a question number 5 where your answer is a decimal. That's one that's already typed up for you. Just recognize that sometimes you might end up getting decimal solutions. All right, number 6. Take 3.5 times D and 21 times 1.5. That will get us 3.5D equals 31.5. Divide both sides by 3.5 to get D equals 9 for our solution. All right, let's give you a chance to try some on your own. There they are. So we're going to go ahead and take a look at these. Go ahead and pause your video, give these two questions a try, someplace where you have some space, and then we'll take a look at the solutions when you're ready to start again. All right, I hope these problems went pretty well for you. Number 1, you should have gotten 38 for your solution. 270 times x and 45 times 228, which is 10,260. Divide both sides by 270 to get x equals 38. Number 2, we have 3.6 times x, set that equal to 2.5 times 32.4, which gets us 81. Divide both sides by 3.6, and you get a solution of 22.5. All right, let's go backwards here a second. Let's take a look at numbers 10 through 12. We're starting to mix in some word problems related to proportions. So numbers 10 through 12, it says to write a proportion that could be used to solve for each variable. Are there other ways to do it? Yes. But it does ask us to set up a proportion, and then we'll solve this. I want to talk about this box down below, though, where it says that unlike dimensional analysis, where the same labels go diagonally, The labels and proportions go in the same location. The difference is that in dimensional analysis, which we saw previously this unit, you're multiplying fractions, and that's why we want our same units to be diagonal, whereas with our proportions, we're setting two fractions equal to each other. So equal means same, so our same labels go in the same positions. All right, number 10, we've got 12 fish in 4 aquariums. 9 fish are going to go in how many aquariums? Well, we're going to set up a proportion. The reason why I see this is because for problems like 11 and 12, it's not as easy to figure out mentally like this one is. You probably know or you can recognize that there's 3 fish per aquarium, so you can figure out how many aquariums we need for 9 fish. But I choose my labels here. My labels are fish, and aquariums. And I can put either one on top. I just keep them in the order they're in. Fish over aquariums. So our first fraction is 12 fish in 4 aquariums. So 12 over 4. Our second fraction, we have 9 fish. So 9 goes on top. And X aquariums, X goes on the bottom. Now, is this the only proportion you could write? No. You could actually have 4 over 12 equals X over 9. You could actually have 12 over 9 equals 4 over X. So there's a lot of different ways to write equivalent proportions that will work, but you'll get the same cross products. So here we are going to do 12 times X to get 12X, 9 times 4 to get 36. Divide both sides by 12 to get a solution of 3. Here is a word problem. It's important to put a label on our solution. We're talking about 3 aquariums in this case. All right, number 11, we're talking about pounds and dollars here. So the number of pounds in weight and dollars. So I set up pounds over dollars. So our first fraction, 8 pounds to $34. Our second fraction, X pounds to $25.50. Now we cross multiply. Take 34 times X and 8 times 25.50. Now, if you want to skip this step and go right to the next step here, which is 34X equals 204, I'm okay with that. As long as you know where the 204 comes from, it's 8 times 25.50. Divide both sides by 34. We get a solution. Keep in mind it's the number of pounds of, oops, I'm trying to delete this box. Just move it down. We get an answer of 6 pounds for this. All right, number 12. We're talking about two different things here. We're talking about inches and hours. So I start off by setting up my proportion, inches over hours. Again, if you want to do hours over inches, that's fine. I just like to keep it in the order it's in the problem. So X inches over 0.45 hours, 8.75 inches over 1.125 hours. Let's cross multiply. 1.125x, set it equal to 8.75 times 0.45, which gets us 3.9375. Divide both sides by 1.125, and we will get a solution of 3.5 inches. Don't forget that label. All right, so those are really straightforward word problems, but we often see ones that are more like actual word problems like these. So let's take a look at these step by step. Number 13, Mrs. Garcia is planning a party for her son's birthday. She knows that 12 tacos are enough to feed 4 people. If 26 people are going to attend the party, how many tacos will she need? So this is a really good real life situation if you're trying to figure out how much food you're going to need for a certain set of people, or if you're making a punch, for example, if you're trying to make a drink and you're making a larger amount, but you want to keep the amounts of each ingredient proportional to the recipe, proportions can work here. So we're talking about two different things in this question. We're talking about the amount of tacos compared to the number of people. So I always start off by writing my fraction, tacos to people, or people to tacos. Now the first part of this, we know that 12 tacos are enough to feed 4 people. So I can write 12 over 4. And now we're going to have an unknown here. So we've got 26 people as our other variable or our other amount. That's going to go on the bottom with people. So I'm going to have a value x over 26 here. I chose t in this case because we're talking about the amount of tacos. So t over 26 in this case. So 12 tacos for 4 people, t tacos for 26 people. Now let's cross multiply. 4 times t equals 12 times 26. That's 4t equals 312. Divide both sides by 4, and we will get a solution of, if I can get rid of this, there we go. Just kidding. We will get a solution of 78 tacos. So 312 divided by 4 is 78 tacos. We always want to think too, does our solution make sense? Well, if we're talking about 3 tacos per person, we've got 26 people. I mean, we could even just take 26 times 3. So I often have students who will say to me, well, I can find my solution without writing a proportion. If the problem doesn't say you have to use a proportion, then that's fine. Then you can do it however you want as long as you show work. But if it does ask you to write a proportion, do that. Number 14 is one of those questions that asks us to write a proportion. So it says the wait time to ride a roller coaster is 20 minutes when 160 people are in line. Write and solve a proportion to determine how long the wait time is when 220 people are in line. So in this question, we're talking about the amount of wait time in minutes compared to the number of people. So I put minutes over people, or time over people. And in the first sentence, we're told that it's 20 minutes when 160 people are in line. So we can write 20 over 160. And then the other value we have is this 220 people. People are on the bottom in my setup that I have here. So I'm going to have a variable over 220. I chose T for time. M for minutes also works. And now once we have it set up, we just cross multiply. 160 times T, set it equal to 20 times 220 is 160T equals 4,400. Divide both sides by 160. The amount of time is 27.5 or 27.5 minutes. All right, let's take a look at a few more. So number 15 is a little higher level here. It says Garcia's grocery store sells Swiss cheese for $2.49 per pound. How much would it cost if Mr. Underkoffler needs to buy 12 ounces? So we're talking about dollars and pounds, but also ounces here. Well, if we're trying to figure out how much it's going to cost if we buy 12 ounces, let's use dollars and ounces instead of dollars and pounds. And we'll show you how to deal with this in just a moment. We've got dollars and ounces. So I set up dollars over ounces. And we know in this first sentence, our unit rate, $2.49 per pound. But we know that there are 16 ounces in a pound. And again, if you don't know that, that is in the first couple of lessons in this unit's guided notes. I will give you any conversion factors at the beginning of a quiz, test, or assessment that you'll need to use for those questions. So 16 ounces in a pound, that means that it's $2.49 for 16 ounces, which is 1 pound. We want to find the cost for 12 ounces. So guess what? 12 ounces. Ounces is on the bottom if I could talk today. So we have C for the cost over 12 ounces. So what is the cost for 12 ounces? Let's cross multiply. We have 16 times C equals 12 times $2.49. That's 16C equals 29.88. Divide both sides by 16 and we will get exactly 1.8675. Let's round this though to the nearest cent since we're talking about how much it will cost. So 1.867, because this digit that I'm going to highlight here in yellow is 5 or above. The 6 is rounded up to a 7 and it will be $1.87, which makes sense. If we're talking about $2.49 for 16 ounces, 12 ounces should be less. All right, let's take a look at number 16. Mr. Myers paid $99 for 12 kids to go to a movie. Find the cost for 18 kids. So we're talking about cost compared to the number of kids. So set up a ratio of dollars per kid. In our first sentence, we know it's $99 for 12 kids, so that will be 99 over 12. And we are trying to find the cost for 18 kids. Kids are on the bottom here, so we have a variable over 18. I chose C for cost. So C over 18, $99 for 12 kids, C dollars for 18 kids. Let's go ahead and cross multiply. 12 times C, 99 times 18 is 1,782. Divide both sides by 12, and we will get a cost of $148.50. All right, number 17. So we've got a couple more of these word problems and then some multiple choice questions as well. So number 17, Gloria paid $1.32 for a dozen eggs at the grocery store. Use a proportion to determine the cost of 4 eggs. So we're looking at the cost compared to the number of eggs. So we can set up a ratio of dollars per egg. We know for a fact that it's $1.32 for a dozen eggs. That's 12 eggs. So $1.32 over 12. And we are trying to find the cost specifically for 4 eggs. Eggs is on the bottom. It won't always be on the bottom. It just happens to be for all of these. So we know that it's $1.32 for 12 eggs a dozen. We want to find the cost C for 4 eggs. So let's cross multiply. We have 12 times C equals $1.32 times 4, which is $5.28. Divide both sides by 12, and the cost of 4 eggs will be 44 cents. All right, number 18. Hillary mixes 4 ounces of red paint with 3 ounces of yellow paint. She decided to create a mixture with 24 ounces of red paint. How many ounces of yellow paint does Hillary need for the new mixture? So working with proportions to keep things equivalent. So if you want to make a recipe that's larger or smaller than what's given, or if you're making a mixture of paint, for example, they do this when they mix different paint colors. If you've ever repainted a room in your home and you go to get that paint mix, they want to make sure that if they're using a larger amount, that they keep those proportions correct. Because if the proportions aren't, the color is not going to look the same. So in this question, we're talking about red paint versus yellow paint. So I did red over yellow, or yellow over red also works. So we know that the mixture is 4 ounces of red paint to 3 ounces of yellow paint. So that's 4 over 3. And we know we're talking about 24 ounces of red paint. So red is on the top here. So we want to have 24 over our variable. I chose Y for yellow paint. So this is one where our variable is actually in the bottom. Let's cross multiply. We have 4 times y, set it equal to 24 times 3, which is 72. Divide both sides by 4, and we will need 18 ounces of yellow paint. All right, numbers 19 and 20, let's take a look at these. These are a little higher level as well, so I think they're really good questions for us. Number 19, Orion can run 2 miles in 19 minutes. At this same rate, how far can Orion run in 2 hours? Round to the nearest tenth of a mile, if needed. So we're talking about miles for sure, but we have 2 different time values. We have minutes and we have hours. I do suggest writing this in minutes because 19 minutes is less than an hour. So what I would do is convert this 2 hours into minutes. So there's 60 minutes in an hour. 2 hours is 120 minutes. Let's do miles to minutes. So we know that Orion can run 2 miles in 19 minutes. That is 2 over 19, 2 miles for 19 minutes. We want to figure out how far he can run in 2 hours, but keep in mind, 2 hours is 120 minutes. Minutes is on the bottom, so we can set this up as m for miles over 120 minutes. 2 miles, 19 minutes, m miles, 120 minutes. So we do 19 times m, set that equal to 2 times 120. That would be 19m equals 240. Divide by 19, and we do come up with an answer of approximately 12.6 miles. We do need to round to the nearest tenth here, so he can run about 12.6 miles. Now, this is assuming he keeps the same rate that entire time. As I well know, we generally don't keep the same rate over a longer period of time when you run half marathons or marathons and so forth, but we can guess that he might be able to run about 12 to 13 miles in this amount of time. All right, number 20. Lexi can text 40 words in 3 minutes. At this same rate, how many words can Lexi text in an hour and a half? So we're definitely talking about the number of words, and we've got minutes and hours in this case. So I'm going to use minutes in this case because an hour and a half we can easily convert into minutes. 1.5 hours is 90 minutes, 60 minutes for the hour, 30 minutes for the half hour for 90 minutes. So we're looking at words and minutes. We know that she can text 40 words in 3 minutes, so that's 40 over 3. And we want to figure out how many words she can text in an hour and a half, which again is 90 minutes. Minutes is on the bottom, so we'll put 90 on the bottom here, W for words on the top. So 40 words, 3 minutes, W words, 90 minutes. We've got 3 times W equals 40 times 90, which is 3W equals 3,600. Divide both sides by 3, and hopefully she's not texting for a full hour and a half, but she can text 1,200 words. All right, let's take a look at number 21. So number 21 is a little bit of a higher level question, but I like it. It says the ratio of the number of students in the chess club to the number of students on the math team is 1 to 3. The ratio of the number of students on the math team to the number of students on the Quiz Bowl team is 1 to 2. We know that there are 4 students in the chess club. How many students are on the Quiz Bowl team? So let's start with this first sentence. It says that the number of students in the chess club to the number of students on the math team is 1 to 3. So I set up a ratio here. Chess to math is 1 to 3. I know, though, that there are 4 students in the chess club. So I'm going to put a 4 on the top for chess. Let's figure out how many students are on the math team. So 1 student for every 3, and 1 student in the chess club for every 3 students in the math club. If we have 4 students in the chess club or chess team, we want to figure out how many students are on the math team or math club. So 1 times m is just m, 3 times 4 is 12. So guess what? There are 12 students in the math club. Now let's go to our second part of this. So we know that the number of students on the math team to the number of students on the Quiz Bowl team is a ratio of 1 to 2. So we've got math to Quiz Bowl. Whoops, that's over here. Math to Quiz Bowl is 1 to 2. I know for a fact there's 12 students in the math club. Put that on the top. Q for the Quiz Bowl team. You can probably guess how many students on the Quiz Bowl team. 1 times Q is Q. 12 times 2 is 24. There are 24 students on the Quiz Bowl team, and that is our solution. You won't have something, so often I go over this question. Students are like, are we going to have something like that on our test? Probably not, but it's a good higher level question. I think it's an important one for us to see. All right, let's take a look at numbers 22 and 23 using unit rates to solve problems. So if I remember correctly, you have something kind of similar to this on your unit test, and we already saw some of these concepts already. So we're just sort of mixing some things together. So number 22, it says, Connor bought 8 cartons of juice for $23.84. Find the cost per carton of juice. So it's a unit rate here. We've seen that since the beginning of our unit. So cost per carton, take your cost, $23.84, divided by the number of cartons. In this case, that's 8. So we'll do $23.84 divided by 8 cartons should be $2.98 per carton. Part B, write an equation relating the cost C to the number of cartons of juice J. This is a proportional relationship. So the cost is equal to $2.98 times the amount of juice that's purchased, the number of cartons. So it's $2.98 per carton. Cartons is a variable J, so C equals 2.98J. That is that direct variation relationship, a proportional relationship. So let's use our equation from part B here to determine how much Connor would pay for 12 cartons of juice. So we replace J with 12, do $2.98 times 12. The cost will end up getting us $35.76. So we haven't done graphing proportional relationships yet, but we might as well see this at this point. So for part D, it says, if this equation were graphed, what would the point 6, 17.88 represent? So in this kind of situation, if we have 6, 17.88, it's going to be 6 cartons and the cost of $17.88. So 6 cartons of juice will cost $17.88. Let's take a look at another problem like this. Number 23. Dorothy earned $72.50 tutoring for 5 hours. Find the cost per hour. So we want to take the cost, $72.50, divided by the number of hours, which is 5 in this case. So take $72.50 divided by 5 hours. She's going to earn $14.50 per hour. Write an equation relating her earnings E to the number of hours H she tutors. So if it's $14.50 per hour, take $14.50 times H, set it equal to her earnings. Since her earnings are $14.50 times the number of hours that she works. Now, just like part C in the previous question, using your equation from part B, how much would Dorothy earn if she tutored for 7.5 hours? Well, in this case, we want to replace H with 7.5. 1450 times 7.5 will get us $108.75. Now, if this equation were graphed, what would the point 9 comma 130.50 represent? Well, if she worked for 9 hours, she would earn $130.50. And again, if this last part D, is a little confusing to you, could be because we haven't covered graphing proportional relationships yet, but if we haven't already, it is something we will be covering very, very soon. All right, moving right ahead to number 24. This is our last question. It says Cooper typed 230 words in 5 minutes during his typing test. Which of the following proportions could not be used to determine how long it would take Cooper to type 391 words? So we're talking about words and minutes. So let's set up a ratio of words to minutes. Now we know for a fact that he can type 230 words in 5 minutes. So that would be 230 over 5. And we're trying to figure out how long it takes him to type 391 words. Words is on the top of this fraction. So 391 over x. X represents our number of minutes in this case. So it says which one could not be used? Well, this fraction right here matches A, so that can definitely be used. So I'm going to cross this one off since we can definitely use it. Something that's beneficial here is to see what this would get us if we actually solved it. Excuse me. So if we would do 230 times x, let's look and see which fractions would also involve us doing 230 times x. So this one would be 230 times 5. This one would be 230 times x. This would also be 230 times x. We would set that equal to 5 times 391. This one would be 5 times 230. This would be 5 times 391. This would also be 5 times 391. So if we would solve these two in the same way we solve this one, then both of these would work, which means that choice B would not work. It would get us a different solution, also the incorrect solution. So B is the one that cannot be used to find our solution. All right, thanks for listening.